Now we'll see the fifth generation dental adhesives. This is a simplified version of the fourth generation dental adhesives. In the fifth generation, the primer and the adhesive are present in the same bottle rather than the two separate bottles, as seen in the fourth generation. Though they require the fewer steps to achieve the dentin bonding, these agents are inferior to the fourth generation in terms to their bond strength. If you observe the commercial products available for this fifth generation is the single bond, one step, Gluma, OptiBond, Solo. The bond strength of the fifth generation is that 25 megapascals. Now is the sixth generation dentin bonding agents. In an attempt to simplify the bonding procedures, the sixth generation adhesives were developed. They do not require the separate etching and the rinsing step. They are of two types. Type 1 is a self-etching primer, type 2 is a self-etching adhesive. In the self-etching primer, the etchant and primer are in the single bottle, while the adhesive is in the separate bottle. The example is the Xeno 3. The bond strength of the sixth generation is about 20 megapascals. If you observe the self-etch adhesive is that in this etchant, the primer and the adhesive are all in one packet, but they require the mixing step before the application of the onto the tooth surface. Example is the prompt L pop. Now we'll go to the seventh generation dental adhesives. They all are true all-in-one adhesives, and this is one of the more recent generation. They combine the etchant, primer, and adhesive in the one bottle. But unlike the sixth generation, they do not require the mixing step before application onto the tooth surface. The example are the Clearfill S, G-Bond, Xeno 4, and the seventh generation bonding agents are very simple in terms of their usage. The bond strength also it's about 25 megapascals. Coming to the eighth generation dentin bonding agents, they are the dentin bonding agents which are introduced very recently. Here, one of the important factor in the dentin bonding agent of this eighth generation is that they contain the nanofiller particles with a high bond strength of 50 megapascal. And it has one step dual coat and self-etch adhesive property. Coming to the another classification of the dentin bonding agent is that it is based on the smear layer. First one is a smear layer removing dentin bonding agent. In this, the smear layer will remove the dentin by the total etch technique. They bond to the dentin micromechanically by formation of the resin tags and hybrid layer. These agents can be subclassified into the etching, priming, and the bonding step, that is a 3-step, and the 2-step by etching, and the priming and bonding in 1 step. Example would be the Gluma and OptiBond Solo. Next is a smear layer modifying dentin bonding agents. Here they modify the smear layer and incorporate it in the bonding process. So they're based on the concept that the smear layer is a natural barrier to the pulp, preventing the bacterial penetration and reducing the outflow of the dentinal fluid that affect the bonding. So they selectively etch the enamel using that as 37% of the phosphoric acid, taking care not to flow the etchant onto the dentin. Later on, they can be washed away and dried, after which the step primer and adhesive combination can be applied. Now we can see other one is the smear layer dissolving dentin bonding agents. That includes the self-etch adhesives, that is the self-etch adhesives consisting of an acidified resin. They usually, on application, they dissolve the smear layer and also etch the underlying enamel and dentin. Since these adhesives are non-rinse type, they infiltrate both the smear layer and the hydroxyapatite crystals of the tooth structure to form the hybrid layer. They are of two distinct types, that is, two-step self-etch adhesive, that is the application of the self-etch primer, and the second step is the application of bonding agent. Example would be the Clearfill SE bond. Next is the one-step self-etch adhesive, that is all-in-one adhesive. Here all the components of the adhesive system, etchant, primer and bonding resin are in single bottle. Example is the I bond and G bond. The self-etch adhesives are further subdivided into the mild etchant, that is mild self-etch adhesives. They have pH around the 2 and they demineralize the dentin only up to 1 micrometers. And they produce a thinner hybrid layer but allow some chemical bonding to the residual hydroxyapatite like 4-meta and a phosphate based monomer like 10-MDP. Next is the intermediately strong self-etch adhesive. They have the pH around the 1.5 and they're more acidic than the mild self-etch adhesives. Hence, they produce the micromechanical bond with the enamel surface, but the hybrid layer in dentin is thin, around 1 micron. Example would be the Xeno 3. Next is a strong self-etch adhesive. These materials have the pH of 1 or less, and their mechanism of bonding to the enamel and dentin is similar to that of total etch adhesives. Example is the add per prompt. Next, we'll see the glass ionomer based adhesives. This is the unique method of bonding that is completely different from other three methods, as it combines the glass ionomer technology and the resin chemistry. Here, instead of etching with 37% of the phosphoric acid, both the enamel and dentin are treated with the polyacrylic acid and washed off. That's how it is very unique when compared to the other three. Now we'll see the recent advances of the dentin bonding agent. We can here add with the fluoride releasing dentin bonding agents also. Now we'll see the acid decalcification concept. When the strong acids such as the citric acid, malic acid, nitric acid used to the pre-treated dentin, it will decalcify the dentin immediately. Whereas others such as the polyalkylic acid, polyacrylic acid will hardly decalcify the dentin on the longer usage also. So there will be self-addition of the polyalkylic acid with that of dentin. That's how the addition decalcification mechanism occurs. Next, we'll see the superdentin. It is the formation of the acid-base resistance zone which was strongly influenced by the fluoride ions released from the fluoride-containing adhesive systems, which may accelerate the remineralization of the dentin against the acidic challenge and create the thicker acid-base resistance zone when compared to the fluoride-free adhesive systems. So this is also associated with the monomer penetration deeper than the other systems. This is about the brief of resin bonding systems.